Графенано, Іспанія, Орнела Тоста. Прошу любити і шанувати. Дякую. Можемо почати. Let's go.
I didn't hear you. I know that you was speaking, but I didn't hear you about what do you said. 1 second, because I need to put the interpretation. Okay. Perfect. Everything is place. So, hello everyone. Thank you for your time, for coming. I'm going to talk about graphene. I don't know if you already know about this new product. It is a Spanish product. We made and manufactured this product in Spain. And thank you, Victor. Custodent is our dealer in Ukraine. So thank you for the opportunity to explain you about this new product. I want to talk you about all the advantage of this new product, okay? I'm going to share my screen. Give me 1 moment. One second. Okay, now, so first I want to introduce myself. I'm Ornella Tosta. I'm part of the Grafenano dental team. I'm the responsible of the technical support department, so I will be the person that is going to be in direct contact with all our customers. So anything you may need when we finish, if you have any question about this presentation, or you are going to start working with the product and you have any doubt, obviously you can contact us directly from Custodent and then with us. I will be very happy to help you in this, you know, if you're going to start working with G-CAM. First, I want to introduce, today we are going to talk about what is graphene, the advantage, and which is going to be the best way of use for this product. First, so you can understand better this new material, graphene, it's an allotropic presentation for the carbon, okay? You know that the carbon we could find in different ways. We can find carbon in the graphite of our pencils. We can find carbon also in the diamond, in our body. So depending how these atoms of the carbon join, we are going to have different configurations and different materials. Graphene has a hexagonal shape, as you can see in the image on the right, okay? And the good thing about this is that it's going to reinforce completely the polymer matrix, okay? Some of the properties that graphene has, in first step, is extremely resistant. It's going to increase all the mechanical properties of any material that we are going to introduce graphene inside. Also, graphene has a specific property that is that he has the capacity to have a conductivity in all the materials. This for the polymers is going to help a lot because we are going to obtain the 100% of the polymerization of our product. This is going to help us to reduce completely the absorption of liquids, and also we are going to have a more stable material. Also, graphene, it reacts chemically with other substances. Also, it is transparent and lighter. For the dental sector, this is very important because graphene is not going to give more weight to the final prosthetic. Also, it's hydrophobic, is going to help us not to absorb liquids for our prosthetic. And also it's flexible and antibacterial, okay, and biocompatible. So this is all these aspects and properties that graphene has is going to help us a lot in our sector, okay? Obviously today we are going to talk about dental sector, but let you know that graphene is a material that a lot of our company, it's introducing graphene in different sectors, okay? Not only the dental, we are also increasing properties in batteries for cars, in medical devices, also in construction. So this is a big world of graphene that is helping a lot of sectors to increase and have new materials. In our case, we are going to talk about G-CAM. Okay, G-CAM is our graphene product. It's a disc that we are going to use with the CAD-CAM technology. And these are the properties of our material. When we talk about the minimal liquid absorption, this is obviously the chemical properties of the product. We are going to have 4 milligrams per millimeter cube. This is, if we compare with other materials on the market, we will see that it's very good property of the G-CAM. So you can imagine a comparative. Ours is, as I mentioned, is 4 milligrams per millimeter cube. Others on the markets, they are around 26, okay? When we talk about also about the residual monomer, as I mentioned before, thanks to the graphene, we close completely the union between all the molecules. So this is going to transform our final product in a more stable and is not going to allow to absorb or have residual monomer. Our residual monomer, as you can see in the image, it's 0.004%. This is very minimum. If we compare with other products on the market, it is around 0.5, okay? Now when we talk about mechanical properties, also thanks to the graphene, we level up the mechanical properties. When we talk about the elastic module and blending strength, flexural strength, you can see the image that we have in the right hand. This is how we measure these properties, okay? So we can measure how our material has the capacity to flex, and when, obviously, we need to take it into the break to see how it's going to support the forces applied, okay? So here you can see that our elastic module is 3,200 megapascals. When we compare with others on the market, they are around 2,000. Also in flexural strengths, we have 140 megapascals, comparing with others that are around 60 or 70. Okay, so you can see that thanks to graphene, we increase these mechanical properties. Also, the superficial hardness, we have 88 Sure D, and also in compressive 155. So this will be our properties in mechanical sector, okay? And then when we talk about the biological, as you know, our material is certified for the definitive prosthetic. We have all the certification for that. Our material is completely biocompatible. Also, it is bacteriostatic and it's not toxic, okay? So all these things are very important when we are talking about definitive materials, okay? Now I'm going to show you some studies because I know that it's important, the background that we have of the product, and obviously for the doctors it's very important for them to see, all the studies about the product. Finally, we have here I only place the most important ones, but we have others comparing with other materials on the market and also clinical cases. But it's important that you know that we have all the studies that talk about the flexural strength and elastic modules, okay, of our material. Also those ones that talk about the microbacterial properties, okay, chemical properties, physical properties. Also those ones that talk about biocompatibility, antibacterial properties, okay, of the product. And also those ones that talk about the thermocycle, okay? The thermocycle are those ones that says how much time the material is stable. In our case, the in vitro test mentioned in this study that our material is stable up to 10 years, okay? Here I always want to make an inciso that it's not the same that my material could be stable in the time that, for example, I could have a fail on my prosthetic. Later, I'm going to explain you about which is going to be the best way to work with our material, because obviously if I don't follow up the recommendation of designing, I could have a fail, okay? In my case, it's not the same, okay? So we need to make the difference between how long is stable my material when we check mechanical, chemical, and biological properties, and in other way to know how to use the product, okay? So which is going to be the best way to apply, okay, the graphene, and which is going to be the advantage of the product. In first step, it's important to know that our material doesn't need or doesn't request any thermal process, okay? We could mill the product and finish the product, okay? We don't need any sintering process. We don't need any thermal process in the oven, okay? So thanks to this, if we compare, for example, with zirconia disc, we know that zirconia need a sintering process. So we need to mill bigger, and then with the sintering process, is going to reduce to the correct size of the crown, okay? Obviously, this is going to make us not to mill so much crown inside the zirconia disc. In case of the G-CAM, we could mill 1 per 1, so we are going to obtain more pieces inside our disc. This is going to give us more rentability, it's going to low down the cost, and also is going to speed the process. About the weight, is one thing that is not studied in the odontology, okay? Because finally we place the prosthetic to the patient, and we normally said, okay, don't worry, you are going to adapt in 1 week to the prosthetic. It's normal that you feel different, etc. But really, if we can provide a material that also is going to give us resistance, is going to give us absorption of load, is going to give us also an easy way of manipulation, okay? It's going to be very easy, okay? And also it's going to be very comfortable to our patients when we place the prosthetic. Here we can see a comparative between half an arch, and we can see the difference on the weight, okay? A zirconia bridge, we are talking about 22 grams versus a G-CAM bridge is 4 grams. If we think about in our natural dentition, the medium of one tooth, it's around 1 gram, okay? If we weight the root and we weight the crown, okay, of this tooth. With a zirconia or metal ceramic, we are multiplying per 6 the weight of the natural teeth, okay? So this is also a thing that we need to think about, that we are going to provide more comfortable for our patient if we have lower prosthetics, okay? About the working time, this is also rentability, okay, for the lab, and also for speed the process when we are doing our prosthetic in the lab, okay? So it's important, this is a comparative of the same bridge made in different materials, G-CAM, metal ceramic, and zirconium, and the time that take us to finish the prosthetic, okay? Finally, we can see that with the G-CAM, the time reduced considerably, okay, in 3.5 hours. Finally, with the G-CAM, remember that we don't need any thermal process. We design, milled, and finish. Later, I'm going to talk about the different type of finishing that we can provide to our G-CAM structure. But if we think about the metal ceramic, we need to have into account that we need to design, okay? After the design, we need to cast the metal or mill the metal, opaque, and then do the layering of the ceramic, okay? This also is more tedious process. It is more longer process, okay? And more manual. And we want to speed the process in the lab to make more rentability and to lower the cost also. So with the zirconia, it's similar. We have to design. We are working in a monolithic way. This is going to help us to go more faster, but obviously zirconia needs hour of sintering process, okay? That we know that we need to put it in the oven and wait until 3, 5, 6 hours, depending on the zirconia and depending also on the sizes of the prosthetic. So, and when we finish, we need to do the glazing and the staining process also with temperature process. So also this is going to take more time in the lab. About our big goal, okay, and the key of our product, it's principally, as I mentioned, speed the process, also the weight that is very light, and the absorption of loads, okay? Why the absorption of loads? Because if we think about in our system, we have in our teeth, we have our nervus, we have our periodontal ligament. The nervus is going to be the one that is going to give us the sensibility, okay? If we have pain or if we are biting so hard and we are suffering, okay, and all this information is going to be transferred thanks to the nervus. And also the periodontal ligament has an important term here, that is the one that is absorbing the loads, okay, when we are biting continually in our daily day. So when we need to substitute our teeth to implants, or a tooth for an implant, as we can see in the image, the implant, we know that is completely screwing the bone, okay? Now we don't have any nervus, and now we don't have any periodontal ligament, okay? So the one that is going to suffer continually the forces that we are doing daily day when we are biting is going to be the implant, okay? So here is a study, a photoelastic study, that is very interesting because you can see how with different materials in 4 seconds, okay, of a compressive force, we can see when we use hard materials like zirconia or metal ceramic, we can see in 4 seconds how the implant absorb all the loads that is receiving, okay? Why? Because finally the material that I use for rehabilitate my patient is very hard, so it's going to transfer directly the force to the cortical of the implant. When we start going down, mixing different materials, like for example metal composite or resin composite, we can see that this transfer of the forces low down. Then also we have other materials that are more biomechanical, for example PEEK composite, or in our case fiber carbon composite. We can see how it completely practically reduces the force that is transmitted to the implant. Why? Because finally we have a material that is resistant but is softer and has the capacity to absorb the load that they are receiving, okay, to disperse completely the load into the prosthetic and not transfer to the implant. For us, this is important because obviously it's not going to be the only reason because a patient could lose their implants. Obviously, also could depend if our patient is smoker, or for example, if doesn't has a good hygienic, okay, internal hygienic. But also if my implant is suffering and receiving completely the impact of our patients, this is going to be also a possible or a reason of my patient implant loss, okay? So it's important also to have a look to this situation. As I mentioned, again, this is our disc. It's a biopolymer reinforced with graphene. Our product is certified for definitive prosthetic. We have obtained the CE and FDA certification for medical device. Our product is a class 2A medical device. So what means this? This means that when a medical device is in the range of a 2 class A, it means that it is for permanent solution, okay? But here in this range, we can find different materials, okay? We can find the zirconia, we can find the metal ceramic, we can find the graphene, composite, okay? Different materials. Now here is when we have to decide what we want to provide or which is going to be the best solution to my patient, okay? So today I'm presenting this new product that is going to give you a new line for solution to your patient. That is going to be a material that is going to have the capacity to absorb the loads. Most important, obviously, when we talk about implant restoration. Also, it's important that you know that we have two different ISOs, okay, that talk about the biocompatibility, okay, and the biological properties, okay, of the product. So in this way, you can be completely safe that you are using a product completely certified, okay? Let you know that we are working in more than 70 countries, okay? We have products around the world. Our experience with the graphene technology comes 12 years ago when we start with the develop of the product, and with the certification of the CE, we have 7 years ago. Our longest clinical case also now it's 7 years in mouse, placed in mouth. Now we are introducing the product thanks to Custodent in Ukraine. So I hope you can start working with it and we can grow together, okay? Now we are going to start in talk about the uses of the product and which is going to be the best way to use the graphene material. So what can I do and what we cannot do, okay? With the graphene, we can do practically all type of restoration, but it's important to know that depending on the type of solution that I'm going to give to my patient, I need to cover some minimal thickness, pontics, cantilevers, okay? Later I'm going to explain about this. But it's important to follow up the recommendation, okay? Remember that Grafen Nanodental has their own technical support department on the company. So if you have any question or any doubt when you are going to start working with the material, please let us know. So with the G-CAM and the graphene, we can do implant restorations, we can do permanent and obviously temporary restoration as crowns, bridges. We can do inlines, onlines, veneers, removable denture, also bite guides for bruxing patients, okay? So it's very huge what we can cover with the graphene technology, but please remember always to follow up the information that I'm going to explain now about the workflow and what I need to know, not only as a doctor, also as a dental technician, because finally we need to work together, okay? So here is the workflow that we are going to follow up. Initially, you know that the patient come to the clinic, okay? The doctor should fill up all the information that they can of this patient. This is going to be very helpful to the lab to finally establish the best treatment, okay? Also for design the dental prosthetic. We are going to receive the scanning, and then we need to plan the prosthetic and which is going to be the best way. This is important. That's why it's important to have a good communication with our lab, the doctor and the lab, because it's going to be the success of the case of sure, okay? I'm going to talk about the CAT, okay, which is going to be the parameters or best parameters for design with the graphene. Also, I'm going to explain you how you are going to mill the graphene, the type of finishing that we can provide, the aesthetic, and also the cementation or the placement of the prosthetic. So I receive, I'm a dental technician, so I receive my case, okay, on the lab, and I need to check, okay, minimal thickness, distribution of implants, cantilevers, and pontics, okay? This is going to help me to define if I'm going to work in a monolithic way with the graphene technology, or I need to use any reinforcement, okay, in the bottom. So we are going to start first with the natural dentition. Okay, if we are going to design a crown, if I'm going to do a veneer, if I'm going to do an inline, okay, this will be the minimal thickness that I need to place on my software of designing. Okay, remember that our material is translucency, is a material that is very aesthetic. So if we are going to talk in the down, as we can see in the veneers, okay, we need to check important the background that we have, okay, because finally it's a material that could transfer the color of the background that we have, also with the crowns, depending on the preparation of the tooth. So if my material is thicker, it's going to have more the capacity to opaque the background that we have. But if I work in thinner areas, I need to check the color of the background, so I cannot transfer, okay, the color that I have. That's why you can see here minimal thickness of the crown, 0.6 in the equator and the occlusion, and 0.4 in the cervical area, okay? In our designing, we are going to establish always in 0.6, because obviously it's the thicker area. I need to be sure that I'm covering that minimal thickness. And also in case of the veneers, also I have, if my tooth is healthy, what I mean with this, that the color of the background is okay, I could go lower thickness, okay, because also it's going to transfer the color of the background and it's going to integrate better, it's going to be more natural, okay? So I'm going to establish my minimal thickness at 0.5. But when my tooth is discoloration, okay, that I want to opaque, I need to go minimum in 1.5. In 1.5, I'm going to start covering the color of the background that I have. So this is important also to know. Or another option will be also to help with the cementation process with opaque cement, okay, in this way. For inlines and onlines, also it's important always to have the minimal thickness established, and I will recommend for a good cementation process always to have parallel walls, okay, that is going to help us to find the enough surface for a correct cementation, okay. And that, let me check, yeah, and that will be for natural teeth. One thing that I didn't place, sorry for that, is that if I'm going to work with pontics, okay, it's important maximum 2 pontics, okay, in a monolithic structure. I cannot place more than 2 pontics if I'm working with natural tooth and I'm working an anatomical bridges, okay, because you have to think about that in the posterior area, maximum 2 pontics, in the front area, maximum 2 pontics also, okay? Now for the implants, that it's more focused for implant restoration, I could work in 2 different ways, okay? I could work using T-base, that is going to be a cementation process, or I have to work or reinforce my structure with a metal bar or any reinforcement material in the bottom. Now I'm going to explain you when it's possible to work with one option or the second option. Okay, so things that I need to check. Minimal thickness. Here we modify, okay? It's not the same as the natural teeth. Okay, when I'm going to work with implants around my abutment, I need to get sure that I have in my emergency profile 1 millimeter, in my equator 2.5, and in occlusion 1.5. Okay, so as you already seen, the minimal thickness change if I'm working with natural teeth or I'm working with implant solution. Okay, in our exocut, I need to place 1 millimeter. Okay, but then you need to check with a cut view the other minimal thickness request around the abutment, okay? Another thing inside our design is to have this enough surface for a correct cementation, okay? What I mean with this is because, as I said in the beginning of the presentation, graphene has the flexibility properties, okay? This material has the capacity to flex, and this is good, okay, for a lot of reasons, but also it's important when we are going to have a cementation process with my T-base or abutments. I need to cover, as you can see in the image, minimum the 50% of the height of my G-CAM graphene solution, okay, or prosthetic. Why? Because I need to find a stability between both material. The titanium is not going to flex. The graphene has the capacity to flex. So if I have a very low T-base, the problem or the issue that I could find on my restoration is a debonding issue, and I doesn't want to find this situation, okay? So it's important to cover minimum the 50% when I am designing, okay? It's very similar. The next right-hand image that we can see here. The first is like the perfect situation, okay? I have my connection like 2 millimeters under my gum. I have the correct minimal thickness, the enough surface for cementation. So this will be the perfect solution for my implant restoration. But we know that not always we have this situation, okay? Sometimes my connection of the implant is very down, okay, on the under the gingiva. So what happened here? If I screw my T-base, my standard T-base, because normally they are very short, what problem I could find here? Okay, I could not ensure the minimal thickness when I go inside my gum, okay? And also when I screw my T-base, the height is not the enough or is not the recommended from Grafenano, okay? So the solution to solve this type of situations is going to be to choose a T-base or an abutment with the correct height of the gingiva, so we can level up a little bit the connection and then have or choose the correct surface for cementation, okay? This is going to help us to solve and have a correct planning of our prosthetic, okay? Now I'm going to show you a real case of graphene. So you can see real cases that in the real situation fail, okay? Because I want to show you not the success case, that I'm going to show you clinical cases with success solution, but I want you to show you also failure case, because not all the companies talk about this. And this is important because if I know and I could go before something happened, this is going to help us to have success case in the future, okay? So we can see here, this case is a Olan 4. We can see different things here, okay? We can see that we don't have any occlusion in the back, okay? We can see also, for example, that we have a overbiting in all the front area, not all the incisors, also the canines are a very over occlusion, anterior occlusion, okay? If we think about this design, obviously we are going to have probably a chipping or a break on the front area because of the over occlusion that we have. But here, really what happened, okay, to this customer was that you can see the height, okay, of the G-CAM and the height of the T-base, okay? The T-base are very short if we compare with the vertical dimension that we have of the G-CAM, okay? So what happened here? Thanks that he only bites in the front, the posterior T-base debond all the time, okay? So the main problem here was the debonding issue of the G-CAM, of the graphene prosthetic, okay? But really this happened because he only bites in the front. So in the back, all the time debond, okay? But imagine that we solve the problem because we have placed a bar, okay? So with a bar, obviously, I have enough surface for cementation. I have all reinforced and everything. But imagine that I don't have the occlusion in the back, okay? And the patient is only biting in the front. If I do a design like this, that is not a balanced occlusion, we have a lot of interference if the patient start doing movements that is natural in our daily day. Obviously, it's going to have a chipping of the front or a break in the front, okay? So remember, if we are going to rehabilitate, but not only with the graphene, really, this is mechanical properties of all the materials in the dental sector, okay? If I'm rehabilitation my patients, it's important to have a balanced occlusion, okay? It's important to have a correct occlusion so I don't have any interference, I have completely balanced with not any contact, premature contact in any place, okay? This is going also to give us a success case in the future, okay? So for make a small resume, remember, okay, the T-base should cover minimum the 50% of the height of the restoration if I don't want any debonding issue, okay? This is a clinical case. It's only one crown, but you can see here also the implant that is already placed, and we can see that the connection is very submerged also in the gum, okay? So the lab, for do a correct design, decide to choose an abutment with the correct height of the gingiva to level up a little bit of the connection and then have the enough surface for a correct cementation process, okay? So this is going to give us a success case. Here it was placed in 22, and then we have the follow-up, okay, in 2 years after, okay? We can see, okay, the color stability, we don't have any plaque retention, we can see the X-ray that the bone continue being in the place that it should be. We cannot see the G-CAM restoration. G-CAM is not radiopaque. We are working on that. So in the near future, we will see also in the X-ray. So we can see, you know, a little bit of follow-up of some clinical cases. Now, these are 3 different designs. Again, what I'm showing here are all real clinical cases that our customers send to the technical support department to review and validate the design. So here we can talk about different things, okay? The first image that we can see in the up, we have 6 implants, as you can see. The distribution between them is really good because we don't have more than 2 pontics, as I mentioned, remember? No more than 2 pontics between implants or pillars, okay? And finally, when we think about an all-on-6, 1 implant is supporting the forces of 2 elements, okay? If we see the image in the bottom, for example, all-on-4, we have to think about that only 4 implant is supporting the forces of 3 elements, okay? So the distribution of forces is not the same if we have 4, 5, 6, or 8 implants, okay? We already know this. So with the G-CAM, remember that if we have a correct distribution of the implants, we don't have more than 2 pontics between implants, we can work in a monolithic way. We don't need to use any reinforcement bar in the bottom and then the G-CAM in the upper, okay? Also, we need to get sure that we have the minimal thickness around the abutment, okay? But if we can see the image in the down, okay, also we can see that we have 6 implants, okay, in the first sector and the second sector, but in the front, we don't have any implants, okay? We have 6 implants here, but the distribution between them is not the best, okay? So this is also a real case. A customer, again, call us, this graphene material, I don't like it, it break, okay? Okay, so in this way, I ask the customer to send us the STL, and obviously when I see and I review the case, I call him again and say, okay, doctor, you can be very mad, but you are not applying the recommendation from Grafenano, okay? You cannot put 6 pontics in the front area, okay? Not only with the graphene, okay? Probably with other materials on the market, in a monolithic structure, this is going to fail, okay? So these type of cases where we cannot get sure that we have more than 2 pontics, okay, as we can see here, it's important to put a bar in the bottom, okay? We put a E bar of any structural material that we can find in the dental sector, and then the G-CAM in the up, okay? What we are having here, we are doing the reinforcement of the structure in the bottom, and then we put a material that is going to give us the same advantage of the graphene technology, okay? We are going to have absorption of loads, we are going to have aesthetic, we are going to have a more lighter structure, etc., okay? Now we go with the Olan 4, okay? The Olan 4 has some issues, okay? It is cheaper because we place less implants, but these type of cases, we need to review correctly the design. Why? Because we can have big pontics, sometimes more than 2 pontics, or we can have big cantilevers, okay? With the graphene, we can place 1 cantilever, okay? But not 2 cantilevers, as we can see in the image. So imagine that our doctor said, okay, but I want this aesthetic. I want two pieces in cantilever because our patient smile and he has a big smile and we can see all the full arch, all the teeth, okay, in the mouth. So I don't want to reduce the size, okay? It's okay, no problem. We can do this type of designing, but remember again, we need to reinforce first with a E-bar and then the upper with the graphene restoration, okay? In case that the doctor, because of the aesthetic, the patient doesn't smile too big, and we can modify our design, removing the premolar, for example, I could leave 1 molar in cantilever and I could work in a monolithic way, okay? In this case, it's possible. The only thing that we need to check in our cantilever, okay, it's that we have maximum 11 millimeters in length, okay, from the mesial area of our connector to the posterior area, okay? Remember, 2 elements in cantilever is not possible, it's going to fail of sure, okay? Maximum 1 cantilever, and remember to reinforce the cantilever. We don't have any support on the back. The only support that the cantilever has is the way he touched the soft tissue, okay? Because it's touching the gingiva, and that's the only support of the bone that the cantilever has. So remember to reinforce to get sure that you have the correct minimal thickness around the abutment, and try not to do individualization like this here, okay? I know that because of aesthetic is important, okay, but there in the back is not so notorious, okay? So it's important that if you are going to do individualization, not to go lower the minimal thickness recommended, okay? So always try to reinforce more and leave the occlusion very soft in this side of the prosthetic, okay? In case that we already know what do I need to check if I can work monolithic or not. If I'm going to put a bar because it's necessary because of the case, okay? You can design the bar with any software. You can use Blender, you can use Exocad, 3Shape, the way as your lab work. The only indications that I'm going to give you is very similar than when we are going to work with the abutments, okay? So our bar, the same in the abutment, we need to try to cover or design it minimum covering the 50% of the height of the restoration of the graphene, okay? To have the enough surface for a correct cementation, try to design the bar as in the middle as possible of our graphene restoration also. Try to design the bar the softer as possible, doesn't leave any pointing area because it could transfer and make any fracture. Okay, so all rounded, all without any 90 degrees, okay? So then when we have our bar, we start designing the graphene structure. I always use the virtual gingiva to make the union between all the elements, so I have a unique structure. And you need to check that you have the minimum thickness around all our reinforcement bar of 1.5. Okay, that is the same minimum thickness if I work with implants and abutments, okay, in a monolithic way. So my minimum thickness should be 1.5 around the bar, okay? So it's very easy, it's not difficult to follow up this information. Then here we can see already the bar designed, okay? Also the upper, so we have the primary and the secondary already. This is made with Blender software. And then we have finish, okay? In this case, we use conventional acrylic for the pink gingiva, and then we stain a little the graphene. Also, another type of solution could be thimble bars. This type of solution they are using a lot in the USA country, okay? Because for them, they said that it's more easier if they have to solve any issue in the future because they have a complete structure and only they mill crowns, and they do it in separated bridge. So for example, if they need to substitute the molar because something happened, they only take out this bridge and then cement again or mill only that area, okay? And the rest, they leave it the way they finish, okay? So also this is another possibility of reinforcement of the graphene technology or other materials, obviously, on the market. We have the product, okay, of the graphene. We have two different formats. We work with Monochroma, that you know that it's the base of the color, A1, A2 is the dentin color that we have. And Multichroma, please don't get confused with multi-layer, okay? The difference, multi-layer, we have more dark area for the cervical and more light for the incisal, okay? In case of the graphene, we have multichroma, okay? Multichroma, in our manufacture process, what we do is we mix the enamel and the dentin together, both polymers, okay? We mix together, and then we mix with the monomer, okay? So what we are going to obtain is a more translucency resin, okay? It's going to have more capacity to transfer the color of the background that we have. And for example, in monolithic structure for implant restorations, if we work with the thickness of the material, also we are going to obtain different effects because it's more translucency, okay? Let you know that we have two color of bleach, BL1, BL2. Then we have the A1, A2, A3, A3.5, B1, B2, C2. And the transparent, that is, as I mentioned in the beginning, it's for split guides, okay? It's for bruxing patient, for sleepy, okay? That the splints, okay, for bruxing patients. Also, we work with two different sizes. We work with the 98.5, that is the universal, in all different sizes, okay? We can find it. And also we work with the circumstan, okay? But this is not the most used on the market, but let you know also that we can work with this size. This is our shade guide, okay, of the G-CAM, of the graphene. Why we have our own shade guide? Because we are similar than the beta guide, but also a lot of customers use graphene as antagonist of zirconia, okay? So if you want to match the color perfectly with your zirconia or with other products that you work with, it's going to be the best to work with the shade guide because you are going to match better the color that you are looking for. Also for the patient to match better the color of the final prosthetic, okay? So only let you know that you have also that shade guard that is going to help you to match the color. Here you can see a multichroma case, okay? There is all crowns, but you can see the translucency, okay, of the multichroma disc and the aesthetic that we can provide with this material, okay? For the milling, how I'm going to mill the product on my lab, okay? Finally, the G-CAM, we can mill in wet or dry process, okay? We can do it in both, it's okay. So any milling machine that you are working for, you can do it in dry or wet way. The strategy that we are going to choose is going to depend on the software that we have, okay? Also on the milling machine that we have. If you work with Millbox, we have already in the last versions of the Millbox the G-CAM strategy, so you can choose the G-CAM material for the correct strategy. But don't worry, okay, if you don't work with Millbox, you can choose the PMMA, okay? So you can mill without any problem with the PMMA strategy, with the milling machine and the CAM software that you are using in the lab. The tools also are going to be the same, okay? We always recommend to use the originals, but if you are using others on the market, try that they are tungsten burns, and also if they have 2 cuts, it's going to be better for mill the graphene material, okay? For the aesthetic, we can provide different aesthetic, okay? We can do manual polishing. We have our own kit, but you will see that they are very easy to polish, okay? Finally, we are working as a polymer in the lab, but thanks to the graphene, we have other properties, okay? Thinking in a definitive product. Our kit comes with different tungsten burns, polishers of silicons, also a fiber polisher that help us to seal the surface of the graphene and then to give the shining, okay? It has a specific protocol of polishing, but you will see that it's very easy to work, it's very versatile, it's very easy in the daily day for the dental technician. Then we have other 2 options, it's staining or composite, okay? These 2 options, it's light cure process, so it's important to review that which materials are you using for, and also it's important to see the lamp that you are using for light cure, okay? This is important for have a complete final solution for our graphene structure. And in another option, we can use also conventional acrylic, okay? Auto or also thermo, okay? If we use the thermo, it's important not go more than 100 degrees for the polymerization of this resin. And this also could be another option for aesthetic for the pink gingiva, okay? Here you can see the 2 different finishing, okay? In the left hand, you can see the staining, and in the right hand, only polish, okay? Finally, as you can see here, we could provide different aesthetic. If my patient want white teeth, with a manual polishing, I'm going to obtain a really nice aesthetic and very natural, only with that, okay? Only with the polishing. If I want to do a staining, or I need to put, for example, it's a full arch, I need to put the pink composite, okay? I need to do a specific process that I'm going to explain you now, and you're going to see also a video. If we need to do more characterization because it's necessary, okay? Obviously, this is going to depend on the case, on the patient, if it's an antagonist, if it's a tooth that is near to a natural tooth, okay? So it's going to depend in a lot of things. If I'm going to put composite or staining, it's important the graphene structure should be sandblast, okay, with aluminum oxide. Also, I need to clean with alcohol. Then I'm going to start putting my staining or my composite. It's important also to place the adhesive. and then the glaze, okay? So now I'm going to put a video and I'm going to explain you step by step, which is going to be the process for the characterization. It is going to be the same for place the pink gingiva or the staining, okay? It's exactly the same process. You can see that also you can find the G-CAM material inside Exocad. So you will find some parameters already in the software, okay, of the minimal thickness. Once we have designed our G-CAM restoration, we are going to mill it. As you can see here, we are milling in dry process, not in wet, but you can do it in both. The strategy that we choose is the PMMA strategy with the same tools that the milling machine used for it. Remember that we don't need any thermal process, okay? We take out the disc from the anchorage and then start cutting and doing the finishing, okay? I don't need any thermal process, okay? I put, green a little, and start doing the sandblast with aluminum oxide, 110 microns, 2-3 bars of pressure, okay? After this, please don't clean with water, okay, or water streamer, always with alcohol, okay? The alcohol is going to help us to eliminate the grass, it's going to help us to eliminate the superficial tension of the material, and also it's going to evaporate completely. So when we see that it's completely evaporate because my structure is again opaque because of the sandblast, I start applying the adhesive. The adhesive should be any universal adhesive, or for example, if you are using, I don't know, Bredent, you can use Visualink. If you are using Gradia, that is GC, you can use acrylic primer, okay? Normally, all the companies on the market that provide for aesthetic composite or for glazing or any staining, they have their own adhesive before starting doing the characterization. It's important to put it on the lamp, the adhesive, because this way we are going to activate it, okay? Now we start putting the composite. In this case, we are adhering the pink gingiva. If we were doing the staining, we were doing, obviously, putting the cervical color or the blue incisional color, okay? Now we use the hand lamp or stabilize the composite so the colors doesn't mix together and we can do any characterization that we want to provide to the final restoration. So we continue putting all the composite that we need for the final aesthetic. And when we finish, because everything is already okay and the aesthetic is the one I like, I put it again on the lamp, okay, for the final light cure process, okay? This step is very important to having the complete process finished. In case of the composite, as you can see here, I'm using the same kit that we have of the graphene, okay? So I do hand polishing for the composite, really because I prefer. I think that all materials that are polished, hand polished, are going to have a better result, okay, in the future. In case that I put the staining, okay, obviously I need to place the glaze, okay, because the glaze is the one that is going to seal the color of the teeth and it's going to make that they keep there, okay? But finally, always we do the polish, hand polish, and you can see that we do the aesthetic only in the vestibular area, okay? Not in the back or in the bottom, okay? I want that graphene, the graphene material is touching my soft tissue, okay, because of the physiological properties that are very, very good. So only please, if you're going to do any characterization, do it only in the area that we can see, you know, in the vestibular. The rest, always try to do the polish because it's going to be better for our patient. Okay? So we finish. You can see that it has a very good shining and aesthetic. Okay. Perfect. Okay, now we continue. These are some clinical cases, okay, that I mentioned that I want to show you some clinical case. This is the longest case now placed in mouth, okay. We have the follow-up, if I don't forget, up to 5 years. Here I only put 2 years, but if you are interested to see not only these, more cases, please ask Custodent and we are going to provide you with all these clinical cases. And okay, this case, as you can see here, the patients come with 3-class occlusion, okay, a metal ceramic in the bottom, some metal ceramics in the up, natural centrals completely break, okay. So the idea here was to place implants in the bottom, okay, as you can see in the radiography, because of the advantage that graphene could give to these implants, okay. Remember, absorption of loads, okay, and also biocompatible, no absorption of liquids, also the stability, okay, of the occlusion. So finally, we place implant solution, all monolithic, characterization with pink gingiva and some stains, okay, in this case. And in the up, the doctor decided to put a bridge of graphene also. And remember, super important, very important, the occlusion, okay, balance occlusion when we are going to do rehabilitation with any material, okay, but also with the graphene is important, a balance occlusion. And this is the follow-up after 2 years, okay, of this patient. Then we have this young lady, okay, she has not a problem, but a discoloration tooth in the central. She was not happy. So now you can see here the color, okay, of the tooth. In this case, as I mentioned before, when I explained the difference between monochroma and multichroma, in this case, we didn't use multichroma. Why? Because multichroma is more translucency resin, okay? So if I use multichroma, it's going to be more easier that this color of the tooth transfer under the crown, okay? So we use monochroma to opaque the color of the background. You can see here the preparation of the tooth. We try to do more parallel walls, okay? Also to help a little with the friction and also for a correct cementation, okay? And also then 2 years of follow-up of the G-CAM restoration. The same, what I need to check, color stability, no plaque retention, the soft tissue that is continue healthy, okay, and all these things about the final restoration. Also, I have here a very difficult case. Also, it's a class 3A, sorry, a class 3 of occlusion. This patient has already a metal ceramic in the up. In this case, the doctor decided to remove completely the upper and place monoblocks implants, okay? Because the problem of this patient, obviously, as we can see, is the bruxism, okay? So he continually chipped the ceramic and they were doing a lot of repair with composite, okay? Because finally remove this is a big problem when you have natural teeth. And finally, this is the X-ray after 2 years also, okay? Finally, the doctor decided to put implant, and as you see here, also he has a natural teeth here. And we do the graphene structure, and this is the follow-up after 2 years, okay? Finally, we can see, obviously, a little bit of wearing, okay? Because of the bruxism that this patient has. But we can see that the color stability continue to be very good. It has healthy gingiva or the soft tissue. Also, we don't have any plaque retention. Okay, finally, this is very important when we talk about, okay, a definitive material. Another type of cases, for example, veneers. This is how our patient come to the clinic. This is the preparation of the tooth. Again, you can see, okay, that the veneers need to cover a little bit the incisal. That's why the preparation comes a little bit up to the back, to the palate area. Again, with parallel walls, okay, try to have enough surface for a correct cementation. And this is again the follow-up after 2 years, okay, of the veneers. This case already I show you in the presentation, okay? It's 2 years also of follow-up. Also some cases that some doctors in Ukrainian also they are using the G-CAM already, okay? So also we have a lot of doctors that are placing G-CAM restoration in the country already, okay? So you can see here. And obviously some of them also should be reinforced, as we mentioned, depending on the case with any metal bar, okay? So a little bit up to here. 1 second, I'm going to take out the screen. Now, so thank you. I don't know if now if you have any question about the product. I hope you enjoyed, you learn a little bit more of this new product on the market that we are introducing it in Ukrainian country, and we are at your disposal for anything, and thanks to Custodent also for the opportunity.
Thank you, Ornella.
Thank you, Anna. I don't know if someone has any question on, obviously we talk about practically everything. I think the only thing that we didn't explain is the cementation process, but if you have any question, obviously all the documentation is there. And yeah, I don't know if someone want to ask something. I don't know if they have any doubt.
Секундочку. Чи могли ви допомогти з запитанням перекласти англійською?
Наскільки практичного і на практиці, які є довготривалі результати використання адгезивного протоколу, тобто вініри, накладки з цього матеріалу?
He is asking the clinical follow-up. Clinically?
Так, саме так.
Okay. Yes, we have the longest case that I show it now. It is 5. That is an implant solution. It's 5 years now in follow-up. And the case of the veneers also I can share later with you, because when we make all the follow-up of the clinical case, we have photos of 3 months, 6 months, 1 year, 2 years, 3 years, you know. So we can share with him also the veneer case. The veneer case now it's 4 years in mouse, okay? So really we have a lot of experience and follow-up of a lot of cases, so we can share later if he's interested. He can give the contact to Anna, and it will be a pleasure to share with him all the clinical cases follow-up, okay? Also remember, I'm going to add something that on the market we are 7 years now, okay? So our longest case is 5 years of follow-up. We try to do a lot of follow-up of clinical cases so you can see and check clinically how it works, the material. I hope soon we can give you also more and more and more cases, okay?
So there are no other questions. Ну, тож, ми більше не маємо питань ні в кого. Можемо закінчувати. Дякуємо вам.
Okay. Thank you to all of you for being here. Bye. Thank you.